The most important thing to remember when learning a new law or rule in physics is that the rule wasn't made for no reason. It's made to be useful. So instead of trying to remember it as just a piece of extra useless information, try and think, what did the person who created this for in the first place actually intend to use it for? For example, Newton's 3 laws of motion. They're actually useful to help you solve problems in motion and in mechanics. Don't think of them as just an extra thing that you need to remember to get marks on. Try and learn them in a way that actually becomes an extra utility for you when solving problems. So Newton's first law, an object in motion will stay in motion unless acted on by an external resultant force, is genuinely useful to try and understand what a single object is going to be doing at any given time. If it's stationary or traveling at constant velocity, then you can tell that there is no force acting on it. The converse is also true. If it's accelerating or changing direction, then you know that there must be a force on it. And this leads into the second law. F is equal to ma, or force is equal to the product of mass and acceleration, or the rate of change of momentum. If an object is experiencing a force, then it must be accelerating, and if it's not experiencing a force, then it doesn't have any acceleration. So that leads on naturally from the first to the second law. Newton's third law states that every action has an equal and opposite reaction. But a more useful way to think of it is that if one object exerts a force on another, that object will exert a force back that has to be both the same type, the same magnitude, but in the opposite direction. This is used in conjunction with the first 2 laws. If an object doesn't accelerate, it doesn't have a force, and therefore there isn't a second object acting on it. If it does accelerate, it does have a force, therefore there must be another object causing that force, which must also be accelerating.